Hi, today we are going to learn how does a processor work. For this, we are going to focus on mainly the digital electronics. I assume that you are already familiar with the basic digital circuits such as adder, subtractor, multiplexer, demultiplexer, and the other circuits. I'm not going to go into the details of how those circuit works, but the focus would be mainly on how those circuit works together, and we will have a slightly story mode approach, uh, and we will try to understand how computers evolved from being a simple adder or a subtractor. Back in the early days, the computers were just like a simple adder, and the size of that adder would be about a small or a big size truck. And you can imagine that a big machine sitting in a room, and somebody would be just plugging and unplugging the cables to input the data for zeros and ones. Similarly, a subtractor would be another circuit or another machine in the room, and if somebody needs to perform addition, they have to be at a certain place by the machine, which was the adder, and if they want to do the subtraction, then they need to go to the subtractor, and presumably they would be getting a register, a hard copy register, where all the instructions of all the operations that needed to be performed for that particular day would be written. So the register would contain add 2 to 3, subtract 1 from 5. I'm just making it quite trivial, but something like that. So this person here, our smiley face, would be going from adder to subtractor, and then back to adder in order to perform addition and subtraction, and then addition again. That worked for a while, but then it became too tedious and too boring and kind of job. He wondered, like, is it possible that he can sit in one place at a one desk and still can perform both the instructions, still can input the data to either of the circuit by just selecting something else. And that's where he came up with the idea of a demultiplexer. In this simple circuit, we have an adder, a subtractor, and a demultiplexer. Basically, a demux is a circuit that takes one data, and according to the switches S0 and S1, it can output that one data to either one circuit or to the other circuit. So let's say 0 0, S0 is 0 and S1 is 0, then it outputs the data 1 to data 1 into the adder. When you change that to 0 1, it outputs the data 1 to the subtractor. And similarly, there is another demux that controls the flow of data 2, and notice that both the switches are shorted, so basically both have the same input. So 0 0 would be 0 0 for this one and this one. So when you apply 0 0, data 1 will go to the adder, and data 2 will also go to the adder, the yellow line. And when you apply 0 1, the data goes to subtractor, and data 2 goes to the subtractor. So that was working perfectly well, and our little smiley face was, as you can see, smiling, was quite happy. But one day he received a data in register, something like this. He was instructed to perform an addition of data 1 and data 2, and then he was instructed to perform a subtraction data 1 and data 2. And notice that I have added two extra instructions here. This one is the shift register and this one is just save. Basically put the data 1 and data 2 into the memory. I'm not displaying any circuits for shift register or the flip-flops or the memory, just for the sake of simplicity. Because there are two switches S0 and S1, there are four possibilities, and as we will see shortly, you can direct the input, the data 1 and data 2, to four different circuits. So the first thing was to the addition, so he applied 0 0 and the data 1 went to data 1 here into the adder, and data 2 went into the data 2 here, and for subtraction he went 0 1, so data 1 went to here, data 1, and data 2 went into here, data 2, and then to the subtractor. And similarly for shift register, he applied 1 0, and for saving or simply transferring the data to a memory or flip-flop, he put 1 1. And then he noticed that this looks like something that he has already seen. That was actually a counter. So he simply attached a counter with a clock, and what a counter is, it simply outputs incremental, it just increased the numbers basically as with each clock pulse. So with each clock pulse there would be 0 1, so 0 0 0 1 1 0, then 1 1, and if this is more than 2 bits then it will go even further. So because he attached this, now he doesn't need to worry about flipping these switches off. All he needs to do is just feed data 1 and data 2, turn the switch on, and the counter will go through 0 0, so addition, 0 1, so subtraction, 1 1, so shift register, and 1 0 shift register, and 1 1 the flip-flop, or the simply the save instruction here. As we can see here, it goes from addition, subtraction, shift, and saving. Later on, what he did is he simply replaced the data 1 and data 2 with a pre-programmed flip-flops, an array of flip-flops. So now he doesn't even have to worry about inputting the data. He just attaches these pre-programmed flip-flops and flips the switch on for the counter, and you get the results, or you basically feed the data to an appropriate circuit. But that thing wasn't working quite well for all the operations, because it can only work if the first instruction is addition, second is subtraction, third is shift, and the fourth is saving. As the way the circuit is wired, when you put 0 0, it will always go to an adder, 0 1 will always go to a subtractor, and so on. So to overcome that, he came up with another circuit, and that would be this one. Now this looks like a little complicated circuit, but bear with me for a moment, and it it's not that complicated actually. Here is our original counter that controls these two multiplexers. Notice that these are multiplexers, not demultiplexers, so that can take multiple output, and depending upon the values of S0 and S1, it can output either this output, this, or that to here, and similarly this one does for these inputs. And what are these inputs actually? If you look here, these are the flip-flops. Each block, consider it as a flip-flop. Then these are the instruction bits. So first instruction would be 0, and the second bit of the first instruction would be 1. Okay, so what's 0, 1? When you apply 0, 1 here, 0 comes here, 1 comes here, because this is 0, 0, so the first things the first inputs are represented at the output. So when you apply 0, 0, basically you don't have to apply, just turn the switch on and the counter will do the job for you. So for the first clock cycle, these are 0, 0, so here we have 0 and 1. Now that 0 and 1 goes to the select switches of a demultiplexer. Okay, now we'll come here in a second. Just first let's focus on this one. What are these multiplexers doing here is it's just selecting the data. So these are the instruction register and these are the data register, and these multiplexers are selecting either this one, this one, this one, this one, depending upon the inputs at S0 and S1, which are being fed from the same counter. So at 0, 0, it will give this 0. For this multiplexer it will be this 1. For this one it will be this 1. And for this one it will be this 1. So they will be at the output for the multiplexer. So output will be 0, 1, 1, 1. That's our first data. And here it will be 0, 1 from the previous instruction. So 0, 0, 1. 0, 1, the way this demultiplexer is wired, is going to an adder. So this demultiplexer will be connected to an adder. This will also be connected to an adder. This will also be connected to an adder, and this will also be connected to an adder, the red or the brown line here. And the input for these demultiplexers are from the data register, as explained before, 0, 1, 1, 1. So 0, 0, 1, 1, 1 are going to adder. Similarly, from the second register, second data register, I haven't shown it here on in the figure, just for sake of simplicity, but you can imagine that the same figure here would be connected here. I have simply just attached the data directly. So the 1 is coming to the demultiplexer, 1 is coming to the demultiplexer here, 0 and 0. So the second data is 1, 1, 0, 0. And because the select switches S0 and S1 are fed from the same multiplexer as these demultiplexers, they also directs these inputs to the red lines or the brown lines to the adder. So basically, in a nutshell, what this circuit does, as soon as you turn the counter on, it redirects these data to a proper circuit, either adder or subtractor, depending upon these bits here in the instruction bits. So it just goes through one after another with each clock pulse to different instructions, and corresponding data is directed to whatever circuit is appropriate for that instruction bits. And when we program a computer, we basically just write these things. You can replace this flip-flop data with from 1 1 to 0 0, and it will be an adder, and so on. So basically that's what the processor does, and that's all there to it. I hope of some help, and if you like the video, if you don't like the video, if you have any questions, please write in the comments below or hit like, and see you later. Thank you very much for watching.